You know, when you think about HDMI, you think local, right? It's a physical cable.
A tether, really.
Yeah, a tether. You've got your source, your screen, and maybe 50 feet of copper wire if you're lucky.
Right, and past that 50 feet, physics just gets in the way. The signal starts to fall apart.
But today we're looking at a piece of tech that just, well, it shatters that limit. We're doing a deep dive on the NTI ST-IPFOHD-LC.
It's a bit of a mouthful.
It is. But calling it just an extender feels wrong because it's not using copper, it's using fiber optics and IP networking.
And that's the whole game changer. You're moving the signal from an electrical one to a light-based one, a photonic one.
So this device takes the HDMI signal, packs it into IP packets, and just shoots it down a glass tube.
Exactly. And when you change the medium, you change the scale.
Yeah.
Completely.
Okay, let's talk about that scale because it's wild. The specs list two very different numbers. One is, what, about 980 feet?
300 meters, yeah.
And the other is almost 25 miles.
40 kilometers, yes.
Why the huge gap? What's the difference there?
It really just comes down to the type of fiber you're using. That shorter distance, the 300 meters, that's using something called OM3 multimode fiber.
Okay.
Think of it like a wide pipe. The light actually bounces off the walls as it travels.
And that bouncing, it degrades the signal over distance.
Precisely. It causes dispersion. But for that 25-mile option, you need single-mode fiber.
Which is a narrower pipe.
Incredibly narrow. So the light travels in a near-perfect straight line, like a laser pointer instead of a flashlight.
Got it.
Less dispersion means the signal can go, well, 24.8 miles without breaking a sweat.
So you really could have a media server in one town and be watching the video in the next town over.
You absolutely could. And because it's fiber, it's totally immune to RFI and EMI.
All that electrical noise you'd get in, say, a factory or a hospital.
Right, a copper cable acts like an antenna for that stuff. Fiber is glass. It doesn't care. It just ignores it all.
Now let's get to the IP part of the name. This suggests it's more than just a point-to-point connection. It's a network device.
It is. You can run it directly, transmitter to receiver, sure, but you can also plug them both into a standard network switch.
And what does that get you?
That turns it into a distribution system. You can have one single transmitter feeding up to 253 receivers.
So for something like digital signage across a whole campus or a stadium.
That's a perfect use case. But there's a really important catch in the documentation about the kind of switch you use.
Right, I saw that. It says for complex setups, you can't just grab any cheap switch off the shelf.
No, you can't. If you're doing what they call many-to-many multiple sources to multiple screens, you're about to flood your network with a massive amount of video data.
So if you use a basic unmanaged switch, what happens? Your email stops working because it's trying to send a movie to your printer.
That is essentially it, yeah. The cheap switch just broadcasts all that traffic to every single port. It'll choke the whole network.
So what's the fix?
You need a managed switch that supports VLANs, virtual local area networks.
You create a separate lane on the highway just for the video traffic?
Perfect analogy. It keeps the video from colliding with all your other data.
And it's important to note, this is all local area network, right? You can't send this over the internet?
Correct. Same subnet only. No WAN support.
Okay, let's talk user experience. We're encoding video, shooting it 25 miles, then decoding it. There has to be a penalty for all that processing.
There is. It's latency. You're looking at an encoding delay of about 100 milliseconds.
Which sounds tiny, but what does that feel like?
For watching a movie or just looking at a security feed, you'd never notice. It's imperceptible.
But
if you tried to play a video game or even just use a computer mouse on the remote screen, you'd feel it. It would feel a little mushy. That instant hand-eye connection isn't quite there.
But they did include IR extenders, so you can still use a remote control from the far end.
And that's vital. You can point your Blu-ray remote at the screen 20 miles away, and the signal travels all the way back up the fiber to the player. It makes it feel local.
There's also that local loop on the transmitter.
Right, a buffered HDMI out. That lets you keep a monitor right next to the source. It's a brilliant, simple troubleshooting feature. If the faraway screen goes black, you can just glance at the local one.
And know instantly if the problem is the source or the journey.
Exactly.
So this NTI unit, it's really about redefining what local even means for video.
It completely decouples the source from the display. When you remove that 50-foot chain, you can completely rethink how you design a building, a campus, anything.
It's a fascinating piece of kit, which kind of leaves us with a bigger question to think about, doesn't it? If your video source doesn't need to be in the same building as your screen or even the same zip code, What does that mean for how we design our workspaces in the future? Something to chew on.
Thanks for tuning in to this deep dive.